I asked you to send me JPEGs or videos with ideas for shaders. And today we'll try to do as many shaders as possible in as short time as possible. The idea is to have something interesting that would be hard to do with classic texturing. So with a static texture. So for example, Polygon proposes Iridescence on metal. Bikini Bottom Citizen proposes Aurora. Like that. Aurora Borealis. Beautiful effect, very hard to do. Or maybe not that hard, we'll see. So that. Ferrofluid, that may be cool. These are these magnetic fluids that change shape. We'll need to find a video. There's also a microscopic marine algae. Working like this. Okay. And Marcio Fontanella says, Iridescence hack, please. Okay. Oh, thanks, Aldo, for the link. But before we begin, I will show you what we did on the last stream, because the stream crashed 2 times. My GPU just died during this. I don't know what will happen today. We'll see. We'll see. But okay, here's a model. That's a lamp. Okay. It's a street lamp. And now a blueprint. A blueprint contains the lamp with a spotlight. So this is the mesh, this is the light source. And what you can see is that the material is glowing. Okay, the spotlight is shining down, nothing fancy yet. However, both are synchronized. And that's not the whole trick, but that's the first trick. So in the construction script, I have set light brightness and set light temperature. These are my own functions. Let's take a look here again. And now look. Temperature, light intensity max. Where is that? Emission intensity 1, 0, 0.1, 0.3, 1. And it also changes the brightness of the spotlight. 100, 10, 1, and so on. Now the temperature max or min, don't remember which I used, 1000. Red, because it's a black body. 2000, orange. 4500 Kelvin, kinda white, off-white. 6500 Kelvin is the typical thing that we calibrate monitors to. That's RGB white, okay, and 9000 bluish and brighter. So yeah, that's the lamp. But what about using the lamp? I have a second blueprint, street light group. It's bigger, not that bigger to be honest. It's quite simple. And what it has where's that component? Wait a second, I need to find that. Select lamp, construction script. But where does it add a lamp? Oh yeah, add child actor component. So it adds a blueprint as its own children. So blueprint containing blueprints. Now take a look. Let's find the map. Map was called streetlights, I guess, but in the maps folder. Okay, maps, streetlight maps. Oh yeah, here. Dot save. An alley of lights. 2 directions, like that. They are not yet randomized. When I hit play, 2 things will happen. First, each lamp will get a slightly randomized color. Some of them will get a chance of being damaged, so flickering. And then every 2 seconds, another lamp will destroy itself, disabling the spotlight and emission in the material, and fall down. Take a look. randomized colors, some are flickering, and now this happens. And one by one, gradually they fall. Okay. So that's the thing. That's the thing. And now, how were they done? Let me go to this blueprint. Let's go back to the easier map. This map. Yeah. Street lights. Okay, so the single street light in, for example, set light temperature. It sets the temperature of the spotlight because the spotlight has a tick box. Use temperature. Use lamp. Spotlight. Yes, use temperature. And if you use that, where are the variables? Here. Use temperature. Yes. When you use that, you can specify the temperature in kelvins instead of the actual color. And then I do set custom primitive data on the mesh, because this function, it doesn't require dynamic material instance. A single material is fine. You just send the data to the mesh, to the primitive. Data index is 1. Now take a look at the material of the bulb. It has temperature. It's a parameter, but with use custom primitive data enabled, meaning it's per mesh, not per instance, not per material instance. It goes to black body, and this black body does the same thing as use temperature in the spotlight. It gives us color given for a given temperature. You just multiply it by emission strength, which is another thing I send per mesh in this blueprint. And voila, emissive color. So that's how it's synchronized. I'm setting the same black body temperature in both the light and the material. And I use custom primitive data, this thing, because that way I can have many lights and, oh, here I have one, no. Oh yeah. And individually send them the color and the emission strength. So when a light is flickering or false, you know, I update a single mesh, despite them being the same mesh and the same material. Okay. So that's it. That's the whole thing. Unfortunately, no recording of the stream is probably broken. I don't know. I have to check. Mazin says, is the fall simulated or pre-baked? It's simulated. So it's very simple. The mesh, I did a collision. How to display collision actually? Show. Simple collision. Oh yeah. So I just used collision, auto-convex collision. Added some more primitives here. More verts per hull. Here it is. Sorry. And then in the BP, I just enable on this mesh. Where is it? Event graph? No, it's in the group. It's in the group. I just enable simulation. So, event graph. Where was that? That's a custom, yeah. Break random light is a custom event. I assign it to a timer, which is a looping, and every 2 seconds, this event has to happen. Okay. So this is the tick of that event. And by following it, we can see that it does, it takes the child actor, casts it to BP streetlight, so it knows what it is, what components does it have. We take the streetlight mesh component and enable simulate. And the spotlight is attached to that mesh component, so it falls together. And then of course I enable is fully damaged, a property I added to this BP streetlight, because then I know not to update its emission. It's forever off. So there's a branch, is fully damaged, only if it isn't, do animation of light. So yeah, I think that was quite cool to do. Unfortunately, it crashed as hell, probably because with that many lights, each casting shadow, or maybe not, but anyway, that many lights, GPU was taxed too much all the time and just crashed. Because, you know, streaming on Twitch is also using GPU a little. So yeah, when I will put files on Patreon with the next stream, you will also have files for this. So you can just go to Streetlights and just see for yourself how it was done. I think it's pretty useful for many scenarios, not just lights. Okay, so now we need some pretty environment. So to have a pretty environment, I will just open the Streetlights map again. Streetlights map. Don't save. I save that as a separate thing. So save as pretty shader 00 map. Delete the lamps. Okay. This one's too. Alright. Disable the grid. And I will place a single light. Where is it? Street lights. Street light. Okay. Temperature. How to set that? Wait a second. I need to expose that. Temperature max. Instansatable. Save. Temperature min. Instansatable. Save. And let's do for 5 times. Perfect. Okay, we have a lamp for ourselves for our shader testing. Or maybe 2. Why not? Why not? 180 degrees. Little shift that. Okay. Perfect. We have 2 lights for our shader testing. Okay, so the Discord. And let's go. Iridescent spots on metal. Okay, so a noise, probably, right? A gradient, hue shift. We can actually approach it many ways. It can be hue shift. It can be a gradient. Okay, let's go. Let's do this as the first one. So content, new font, pretty shape. First thing we need is some nice noise texture. So, do we need Substance Designer? Probably we do. Designer. But of course I use Designer, but you know, everything is doable in whatever you want. It's just for convenience. Here it is. Okay, new graph, new substance. Pretty shaders. 1K, 1K. Relative to parent. 3D view. Do we need that? No. Unsaved. Let's save. Press level tools, projects. Content, textures. Pretty shaders, SBS. Okay. A new graph. This is the graph? I think so. Let's call it Iridescent Metal. Cool. Add node. Okay, so let's start with some noises. Here they are. Let's look for something that's similar to what Polygon posted. Is it similar? Slightly. Actually, it is. It is. It's a good source. Here it is. Under my webcam. So let's move it here. Okay, now it should see it better. First thing I do, blur. Blur HQ grayscale. HQ is much better because it's circular, not box. So blur HQ. Standard blur is just box. The strength. Where was it? Intensity. Okay, like that, maybe. Oh, not here. Here. Maybe yes. Something like this. Or maybe clouds would be better. Clouds would be better. Okay. So a slight blur. Not that strong. Just slight. Now levels to shift the midpoint a little. Maybe like this. And from this, we'll take these spots. So very subtle intensity of blur. Levels, of course. And let's take only the spots. Something like that. Right? But I will invert them to have these black spots. But let's do it later. Because that will be a separate map, I think. Do I need to blur first or later? Probably doesn't matter that much. Okay. Okay. Like this. So these will be the little black spots in the middle. Okay, maybe that's too small. Let's try. I think there is no dilate, or is it? No, there's not. But we can do blur and then levels. So blur and now this. Yeah, the result should be similar. It's good. Maybe a little posterization. There's posterize or no? No posterize, but we can do gradient map, and this gradient will look like this: a point, point, and a point. And now I'll just do that. Click here, move to the right. Click here, move to the right. And that way, as you can see, it becomes posterized. So it's like a step, not a fluent transition. Okay. Maybe that's even too much, too harsh. More like this, and subsequent steps could be harder. Like that, probably. Good enough, I think. Good. So this will be these black spots on metal. This will be the iridescence, you know, driving the iridescence effect. But this also looks a little posterized, doesn't it? Or maybe not. We'll see. We will see. Maybe this noise is just too complicated. Let's go with a smaller one. More blur. Okay, maybe something like that. Oh, hi Roy, and hi Mateus. So give me a second, let's hydrate. Let's look again at the reference. It will be like this. But of course the iridescence, it depends on the angle of looking at it, right? So we can't bake the color, but I can, let's say, simulate you what I would like to do. So gradient map, this input, on the gradient we will have a full rainbow. There's a nice trick, take a look. I open the reference. Reference, come here. Come on, reference, come on. Move. Okay. In Substance, there is gradient editor. There's pick gradient. Take a look. Now I leave the mouse. And the gradient is recreated in Substance. I can of course pick a smaller one like this. It's here. Okay? It's of course too complex, but it's fun. Again. Here's my gradient. And now I take this gradient and I take the clouds as input. So the brighter the pixel, the more to the right will be the value that it chooses. So black is the beginning, gray is the middle, white is the right side. So basically brightness will be the x coordinate of this gradient. Looks like this. Not the best gradient. Let's pick again. Pick something much smaller, like this. Or maybe bigger. Maybe. But now we have a problem because this map is too complicated, as you can see. A lot is going on. So maybe we need just more blur. It makes it smoother. So it makes the shapes smoother. This is more perturbed, which is good. But we don't have the nice continuity that we see on the reference. That's because I think there are too many dark and like interchanging shades in this. It should be much simpler. So instead of doing this, let's do, there was I think a rainbow, or was there? There was something with a rainbow thumbnail. Give me a moment, I'll find that. Because definitely there was a rainbow thumbnail. And we can pick from this. Or I remember wrong. Maybe there wasn't. Oh yeah, here it is. Look. Gradient editor. Pick. Better. Or maybe the other way around. Like this. Cool. Too much green. This one. Slightly better. It doesn't wrap though, so it's not the best. It's too short. Oh god damn it, if I only had a rainbow texture somewhere. Now we have a problem because it's unbalanced. Unbalanced completely. Has to start with blacks. Has to be fairly normalized. Now the hues are too intense. So after getting such a gradient, we will need saturation. How is called saturation in Substance? What? HSL? Yeah, HSL. Saturation down. Closer. Too much green. Too little yellow, I guess. But it's more like it's magenta, blue. There's no pure red. Right. And the green is only slightly between cyan and the rest. The distribution is different. Let's make a manual map. I'll just delete all this. Clear all. And let's just do exactly like the colors. Like pick. Where's pick? Yellow. No, yellow is on the white side. Here pick. The magenta. Here it would be the blue cyan thing. HSL won't be needed then. Okay. We need more. What's between? Let me zoom into this. Oh, Piatnashkin says that this color contains the color. Article contains the color table. Oh wow. That's perfect. Thank you. I don't have to pick that stupidly. I can just use the reference. Perfect. Thanks a lot. Let's delete. And again. gray. Come on. Just pick that. Pick. What? Wait. Something's wrong. Pick. Grow. Okay. Next one. Next one. Hello. Kornblumenblau. Dunkelblau. Violet. 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 Gelb. Goldgelb. Stillgelb. Weißgelb. Okay. Let's redistribute them a little. Thanks, Piatnashkin. This is actually brilliant. So even the green is not here. Okay, good. Now, as I said, something's wrong with the distribution, really. Because we're not getting a proper effect. Should start with this, sure. Maybe, I don't know. Reference. There's more of this gold. Gold, like this, or something like that. But at the same time, where's this gray? Where is it? Only now it shows up. It's very, very weird. Wait a second. Let's blur maybe less or more. Ah, it changes not so much, just the shape. Actually, we even don't have to blur it. Let's try another texture. Let's try this. This is different. Okay. This one could be better. Let's mix them. Let's do levels on this one. And let's blend them together. Opacity like this. Ah, this should be blurred. Wait a second. This one should be blurred. Go here. Okay. This one should be blurred as well. Go here. And now what? Now the result should be nice. Let's try. Ah, and levels, of course. More equal, even distribution. Good, I guess. And now gradient map. This should be different, I guess. More of this bright gold. But I wonder if this red should be really that intense as in the table. Because look at this, this is not that intense. So we might cheat a little. I will reduce saturation later. Okay, HSL. Oh, too much. And too much of this gray stuff. So it's too dark. Yeah, more like this, I guess. And less saturation again. Actually, only this red bothers me. Let me take that red. Desaturate it. Now it's closer to the reference, I guess. This could be brighter. More like that. Okay, cool. Oh, Roy says the memories from my times at the forge. You work at the forge. But of the reenactment, like historical swords or something? Or just working at the forge? Roy thinks that the temperature coloration on the metal is normally affected by the color of the original metal. So you mean that it's different depending on what metal was used, right? Thanks, Piatnashkin, again for that reference table. Okay, so we have this. This is a kind of simulation of the gradient and of the texture. So let's output this texture to Unreal and this gradient. Output, it will be iridescent metal, noise, mask, format L16, okay. And now gradient map, we should use it on just a linear gradient. Gradient linear, rotate it 90 degrees, like this. And let's save this to Unreal. Let's save this to Unreal. It will just be smaller. So absolute terms width will be 32 pixels and height would be 4 pixels. Just like this. 4, because when you do compression on the GPU, you need at least 4 pixels. I won't use compression, but you know, just in case. It's not that bad. Okay, so noise and the gradient. Gradient output will be called iridescent metal gradient D. Diffuse color. Let's export. So yeah, that's the reference. Let's export. There's one thing, when you export from designer, you have to right click, compute outputs, and only then export textures. Export as bitmaps. Process level tools, content, textures, iridescent metal, noise mask. Perfect. Export outputs. Now Unreal. And let's import them. Process level tools, content, textures, this and this. Go here. Okay. This shouldn't be compressed. So let's change compression settings to vector displacement map, because this is one that's lossless. sRGB, yeah. Close it. This one should be grayscale. Red. And now material and iridescent metal. Let's bring here the material. No, the mesh. Mesh. Where is it? Come on. Yeah. Let's put it here. Maybe 2 times bigger. 1.5 times, okay. Okay. Slightly in the shadow. Oh, this could be somewhere else. Okay. And let's put this material on them. We can enable shadow casting. Spotlight. Cast. Spotlight. Cast. Oh, they are slightly hovering. Why? Okay. They're in a good spot. Let's place the material on them. Pretty shaders like this and like this. Nothing is here yet. First thing, the noise. Let's take a look at that. Okay, that's the noise. Perfect. Now, the iridescence itself. Iridescence itself. So look, I have this gradient that I made in Designer, right? And the same trick as with the gradient map here. So as I mentioned, where's this? The luminance of the pixel will be the x coordinate, the u coordinate of the UVs. So if you treat the gradient as a texture and want to sample this, you use the luminance of the noise as the x coordinate along that. So I will show you in a second. I bring it here. That's the texture. And we create our own UVs. The UV Y will be half. So precisely in the middle. Okay. So append. I append half. Of course, now it doesn't matter at all. But imagine you have multiple gradients. You have to pick this accordingly to fit right in the middle of a gradient. Piatnoshki says the image sourced gradient was the best so far. So yeah, there is a gradient resource in Unreal. It's called Curve Atlas. And normally it's very good, this Curve Atlas thing. I don't remember where to find it. Somewhere. In the materials, maybe. Or miscellaneous. Miscellaneous. Curve Atlas. You can do gradient here. I don't remember how. Gradient curves. You add one. And you need a curve. Okay, so also do miscellaneous curve. Curve type linear color. New curve base, you drag and drop it here. And you put some colors here. So add opacity, sorry. So in the middle you do green, somewhere you do yellow, like this. Okay. Curve gradient. You curve asset. You save it. You put it here. New curve base. And what? Nothing? What the hell? Save. What? Why? It doesn't update. Actually, why? Should work. Chat, help me. Why it doesn't refresh? Maybe I close that. Yeah. It refreshes. Sorry. It refreshed and it's just too small. Let's do 32. Yeah, now you can see it. Can you see that on the top? The problem with this stuff is, and I honestly don't know any explanation for this, that the size is always square. Or maybe it's not. Maybe it's now. Yes. So they added the possibility to not non-square it. Just disable square resolution. Oh yeah. So this may be actually good to use. Okay, so you put the different curves, the gradients here, and it packs it for you into a single resource. A texture in general. Nothing is different. It's normal texture. Format is float RGBA. So even heavier than your typical textures. And then in the material, you just use this. Just sample the curve atlas. And you still need UVs, but you can get them curve atlas row parameter. Curve time is of course our x, so the same as x coordinate here. And here's the color. So you can basically put a curve, an atlas, or a curve, whatever, and then you can sample this. So that's the way if you don't want to use designer or something to output gradients. Basically an easier way because you just edit them here and you have them. But honestly, I'm also not such a huge fan here because I prefer better control in designer. Not to use this. However, when they added this non-square resolution, it's much better, much more useful. So give it a try, I'd say, and you will see for yourself. Slider, we are doing this. So there's a metal. Metal has some spots and so on, and there's this iridescent effect. So you know, this metal is like colorful, kind of like effect on petrol as well. So for this we created this beautiful texture, this noise, and a gradient of iridescence based on article that Piatnashkin sent, which is the colors of iridescence and actual temperature. So yeah, let's go. I did that. So again, y-axis is our, let's say, row. Currently we have only one gradient, so it doesn't matter. And x-axis is the luminance. So take a look. We take this luminance, put this to UV, red. And instead of this base color, we will have that. Beautiful. However, it doesn't look like iridescence, right? It looks like a stone, because when we move the camera, nothing happens. Oh, also there's a seam on the UVs. So instead of the texture sample, we can use local aligned texture object. Use the same object here. Normal is just default. XYZ texture. Component mask, red. So we have this ugly seam, and with word aligned texture, it should no longer be a local aligned texture. It should be a problem, I think. But it has only so few options. Like, where's the word position stuff? Ah, I don't like it. Aligned. Let's do word aligned texture. Separate channels. Oh god. Word aligned texture. Cool. XYZ texture. Texture object. Texture size will be metal texture scale. I don't know, 100? 1 meter. And word position will be local position. So that if we rotate the object, it doesn't move. Like this. Word space normal will be our normal word space transform to from word space to local space. And here, word space normal. So it's word aligned texture, but we actually replace that with local position and normal. Let's try. Perfect. No seam whatsoever. We rotate the object, behaves correctly. So yeah, this is like a word aligned texture, but it's local aligned. I rotate the object, it stays. That's because I use local position in word position and transform the word normal to local space. Okay, so as you can see, this texture, its luminance serves as the x-axis or the u-axis of the UVs of a gradient of this. So now, why does it look like a stone? That's because it doesn't move with the camera. So now another topic will be, Slider says interesting, thanks a lot. So look, Fresnel, or not Fresnel, just dot. Dot product gives you the angular relationship between two vectors, basically. When they are totally opposite to each other, it gives you -1. When they are perpendicular, it gives you 0. And if they're exactly the same, it gives you 1. So the result is between -1 and 1, depending on how the two vectors are facing each other. So I take camera direction vector? No. Oh, add there. Take a look. This is what you asked about. The constant direction of the camera. That's it. Camera direction vector. And I want not this. I want view vector. Camera vector WS. So this camera vector is different. This is the orientation of the camera, where it's looking. And camera vector is direction from the center of the camera to each pixel. Yeah, to each pixel. So on the edges, you got a slightly different, slightly rotated vector compared to the center. But it's good. So it's like an observation vector. And if we compare this with normal, word normal, pixel normal, workspace, we compare, the direction of observation of a pixel with its actual normal. Normals, of course, face outwards of the mesh, right? We compare that, saturate the result, so clump it. Let's put it into base color. Here it is. Looks like a flashlight because in the middle, the vectors are identical. The vector of observation and the normal of that are the same. And then, so that's the vector from the pixel to camera. And on the edge, it goes towards 0 because they're perpendicular. Behind, we can see that it will be -1 gradually. So yeah, dot product of camera and pixel normal. Now let's remap that. Remap. Because it's slightly too bleak, let's say. So let's remap, for example, from half to 1, such that the result is between 0 and 1. 0. And of course I have to saturate, which means clump again. Yeah, so as you can see, dark on the very edge, white when it's exactly facing the camera. So the typical Fresnel effect, okay? Dot product of pixel normal and camera vector. Let's move this down. Let's move it down and let's call it, go here, and let's call that metal texture. This will be called sample the gradient. And this thing maybe 0.1 will be enough. And we can add a power to this because look, the transition is kind of very smooth. Let's apply again. So let's add power. power to the third. Now it should look better. Yeah, much better. And this we can use. So this is a camera facing gradient. Kind of like Fresnel. And this we can use to sample the gradient. Okay. Here it is. Take a look. It's exactly as advertised. Almost, exactly. Maybe the power is too high now. Maybe it's just 1.5 would be enough. Let's see. It will give us more of this yellow thing. Oh yeah. Very good. So now, having this, we may a little perturb this gradient with this texture. So here we have texture. Here we have this gradient. This, not gradient, but this camera facing gradient. First things first, we can actually add, but overlay may be better. Overlay may be better or not. Wait, what do we need to do? Let's try it in designer. Because I have, let's say, a gradient. Let's make a new one. Linear grad. Okay. Gradient like this. And what I want to do, I could actually multiply. Maybe that's the idea. Blend. And multiply that. But multiply will make it always darker. So maybe instead I could do something like overlay. That'd be perfect. That would be perfect. Okay. Let's go back here. So overlay math. There is a very complicated overlay blend, which is like insane. Like, sorry, Epic, this doesn't make any sense whatsoever. Overlay is done like this. And you know why this is so complicated? Because it's moved straight from Photoshop, and Photoshop in the original times, they didn't have 16-bit or 32-bit. They couldn't go above 1. So they had to do all this mumbo jumbo to stay in the range 0 to 1. So 0 to 255. We don't need that. Overlay works like this. You multiply the overlaid texture by 2. So 0 stays 0, half becomes 1, 1 becomes 2. That's because in overlay, the midpoint is neutral, white makes things brighter and dark makes things darker. So it's like a multiply but times 2. And again, multiply with this texture times 2. You saturate and that's it. That's absolutely it. So the original looks like this. And now with this gradient, looks like this. Overlay. That's it. Overlay. Blending. Not this heresy. Whatever that is. With 3 ifs and appends and recombine. Oh god. Okay. Here. And now take a look. I can use this to sample the gradient. So gradient. Luminance of this will be used as the X position. Y is just constant half. Let's try. Kinda. And now take a look. If I rotate, this also moves. Okay, so that's the difference. That is no longer, doesn't look like a stone because it moves. It's affected by the Fresnel, by this. So again, just to compare, this is just based on the texture. Looks like a stone because when I move, nothing changes. It sticks to the surface. And now perturbed by such a gradient, by this gradient, combined together with an overlay blend, and only this drives the gradient. It looks like that. Actually, I maybe not need that power here. Yeah, not needed. Cool, we got that. Not yet, Metalness. So, roughness, I don't know, 0.3 or 4. And Metalness 1. Base color is here. Maybe it's slightly too saturated. The saturation. Or no. No. I should lerp between normal metal and this. By normal metal, I think of something like base color should be like 0.8 gray. Okay, and I call that Iridescence strength. Sorry. Okay, iridescence strength is 0. And gradually, let's apply that. 0.7. Here it is. Iridescent metal. Okay. Piatnashkin is satisfied with the result. Yeah. Okay, let's hydrate and let's go to another one. Eloy says nice, thank you. Let's hydrate some more. Piatnashkin says it finally clicked when I made it metallic. Yeah, I agree, yes. And look how crude it looks in Designer. Like how bad it is. And then when there's lighting, shading, you make it a little less intense. How much difference does it make, right? Piatnashkin says, time to release it on Marketplace for $200. Yes. And call it Iridescence Metal Technology. Per pixel physical calculation. Okay, that's the one. Oh, and if I add a little brush to normal, I will sell the fantasy 100%. Huh. That's what Roy says. But do we have such a texture? We don't, so we have to export. Where was that? Noises. They had something like that, right? Such a grunge map. There was definitely something. Or we can make one. Oh, let's use this one. Just more tiling. Let's try this one. Tiling. Transfer. With 33%. Normal. Okay. It needs the high pass. High pass grayscale with a given radius. And then the normal. And the blur, I think. Blur. Yeah. Strength 50. So this combined with another but of smaller frequency and smaller blur at smaller intensity. Cool. Normal combine like that. Yeah, right. Smaller intensity again. And let's export. Output. Identifier. Oh, what was it? N. Just N. Compute. Export. Export. Close. And now we have it here. This is normal, normal. Bring it here. And now we need polar coordinates, right? So we need coordinates around this metal. How to do that? How to do that? Polar. Is there ready-made polar thing? Polar angle 0, 1. From the UVs. Okay. So my UVs could be my top projection. UVs top projection. So UVs will be where local position. Component mask. RG. No. RG, yes. Let's say what it results in. No. Arc tangent. No, please. I don't need that. Or maybe do I? From 0 to 1. Wait, it takes UVs from 0 to 1. I need local bounds. UVW. Bounding box based 0, 1 UVW. I need a red and green combined, so pen. Because this is a mask, right? Wait. Point to it. Use it. Yeah, this is such a mask. Ideally aligned to the object. X, Y, and Z. So I append to have only X and Y. And now to my polar angle. I'm not so sure, to be honest. Why is it gray like that? Maybe it's from pi to pi. Let's see. And as the yeah, and the distance from the center. So distance from this to 0, 0. No, sorry, to half. Yes, this is the distance. It will be my v coordinate. So let's append both. I'm trying to do a texture that goes around an object. So like an anisotropic, let's say metal. So append. And now I need to multiply it by tiling. So v metal normal tiling xy. Append also. And multiply. Default will be 1, 1, and let's see what it results in. Okay, and now I can multiply, you know, like this. Okay, is there a checker I can test? Yeah, checker. Let's try. Preview. No checker. Tiling 10, 10. Okay, good. So I need more tiling in the x-axis, definitely, like 30. No, it's weird. There's polar angle from the UVs. Or maybe the UVs have to be centered. Oh god. So maybe I need to add minus half. I don't know. I don't remember. Weird. This is correct, I think. How does this work? From minus pi to pi, arctangent fast of UV. What's wrong about this? They should be from minus 1 to 1. Okay, sorry. So we have this bounding box based. We remap them. From 0, 1. Remap is one axis. God damn it. Multiply them by 2 and add minus 1, minus 1. So this stuff, remap 0, 1 to minus 1 to 1. How to type it? Maybe like that. Okay. Still bad, but actually why? I don't know. There's this tiling. This by distance actually works. So like that. So what's going wrong with this arctangent? Um, it always says that maybe we don't need a normal. Huh. However, maybe some of you has an idea how to actually get, you know, the round gradient. So radial, not radial, gradient. How's it called? You know what I need. What I need is this 0, half, 1. That's what I need. How to do that? I thought this does it. Arc tangents in radians from -pi to pi. Yeah, so look, Regomir inside. I have this UVs, arc tangent fast, and I remap it from -pi to pi to 0 to 1. 8 done. Arc tangent, yes. 8 done. So now the question is, or maybe it should be arc tangent 2. Arc tangent 2. Okay. Okay, so maybe that's why we had a problem in shader toy. If you say it's arc tangent 2 fast, then that's what we need. Oh god. And nobody told me. Break block 2 components. Now there's a trick. Look. G goes to Y. R goes to X. Arctangent 2 has a weird order. Probably consistent with mathematical notation or something. Okay, let's try now. Nothing. Nothing? Oops. Okay, now. Now! Yes! Thanks a lot. Other person of the day. Just take a look. I was using arctangent instead of arctangent 2. Here. Perfect. So now we have our coordinates. Now we have our coordinates. So it means we can use them for our texture instead of a checker pattern. Preview. Beautiful. I need to rotate that. Rotate, transformation, 90 degrees. Okay. Save. Export. Yeah. Reimport. Great. Great success. Let's delete that and now use it as a normal. And if we use it as a normal, it will also affect the pixel normal, which is very good. So let's put it here. Okay. So all this is polar coordinate around the object. Good. Normal map. This goes to the bottom. And save. And stop previewing. Stop previewing. Okay, cool. Take a look. Okay, it's too strong. Normal flatten. Normal flatten, normal. flatness. Great. Take a look. Shiny metal with iridescence. Perfect. This one is done. Let's close it. Let's submit that. Pros level tools. Iridescent metal. Roy says it's nice. Thank you. Okay, next example. Let's go here. Lego mid. The reflection color should be shifted. Maybe, yes. What do you mean? That its reflection should be of a different gradient than this base color? Huh. Because it should absorb different color. Okay. I don't know how to do that. Probably I need a clear code or something. But I mean, I believe you are right. But I don't know how to do it. Physically, probably you're correct. Okay, this is done. Oh no, this is the hardest. Aurora Borealis. How to do that? How to do that? I don't know. Let's leave it for the next stream. Sorry, Piatnashkin, but if we start now, it will take like probably an hour. But we'll return to it for sure. Ferrofluid that interacts with geoproximity. Okay. So, Ferrofluid. Fluid. First things first. It should be black and shiny. Not totally black. 0.65. And shiny, meaning very low roughness. Okay, perfect. Maybe even too dark. 0, 1. Okay. Hi Baptiste. Welcome to the chat. And hi Admiral Vroga. And hi Biolash. Nice to see you. You mean that the frame rate dropped? But now is it better or not? Now when I rotate, it's good? Or not yet? Is the stream smoother now? Looks okay. Okay, so unfortunately, yeah, this is when the CPU or GPU is too absorbed and then the compression is losing. That's, there's no compute power left for compression of Twitch. Sadly. I don't know actually what I can do about it. Arbus Vertex, hello, how are you? I think the ideal solution, which is beyond my budget, would be to have a capture card and make this card stream. But yeah, basically a separate mini computer that captures the video and is unaffected by the GPU usage of Unreal. But yeah. Okay. Ferrofluid. We need some proximity. Proximity to whatever for now. So if we don't care proximity to what exactly, then we'll just make a point. To easier control that point, I need to send this point to the shader because I can make a vector. It will be magnetism or magnetic origin. Okay, it will be in a world space, so I get vertex world space, world position basically. Okay, absolute world position, excluding material shader offset. That's because we want to do an offset. So you know the world position offset probably, but if no, I will show you. Let's say we got some noise. Let's display this noise. Should be very simple. So fast gradient, one level. Okay, output from 0 to -1 to 1 is okay. That should be bigger. So scale 0.1. Okay, right? That's a noise. I multiply that by displacement strength or displacement, displacement distance. By default, 10 centimeters or 20. I multiply the result of the noise, multiply it by vertex normal. So multiply it again. Remember to multiply vectors by scalars, not the other way around. It will look like this. And I will use that as the vector of world position offset. Here it is. So look, displacement distance 0. I start to move that. And the vertices, they move. So that's world position offset. You take world position normal, scale it, and basically this offset is added to the world position of a vertex. Now the problem is it doesn't update normals by itself, so you may need to recalculate them. I don't know if you can derive them. Probably not. Probably there's some function. I don't care right now. The thing is, the vertex is moved. I need a denser mesh. So tessellation was unfortunately removed in Unreal Engine 5. There is nothing like tessellation, I think. Yeah. So I need a denser mesh. So let's go to Blender and tessellate. Mazin asks why multiply vectors by scalars and not the other way around. That's because multiplication is component wise. If you multiply a vector, so that's, you ask if this is an industry standard. It's more like a mathematical standard. In Unreal, both ways work, but not everywhere. So it's better to have that habit, I think. So imagine vector. You have x. You have x. You have y. And you get some z, right? Now, if you multiply such a matrix, because it is a matrix, by, let's say, number 3, or by number 2, then the result is, of course, this times 2, this times 2, and that times 2. Okay? And again, as a vector or a matrix. However, if if you had just 2 and then try to multiply it by matrix. So this means that in some systems it will show this as an error because it knows what to do here. It multiplies 2 by the first number, and then it has 2 fields left because let's say the scalar already exceeded its length. So yeah. Probably Legomir can explain this to you mathematically better, but in general, outside Unreal, I recommend to multiply vectors by scalars, not scalars by vectors. Okay? Legomir says it's from the fundamental rules of linear algebra. Now about this, wind-decided mesh. So Blender Launcher, sorry for the very old version by now. I know 3.0 is the modern thing, but I am not modern myself, so sorry. I started on Blender 1.8 in my childhood. Essentials Cube, where was it? Oh, not Essentials, it was in Common. Come on, Models, Shader Test Sphere. Okay, subdivide. Export FBX. Shader Test Sphere. Dense. Okay, let's import that one. This will be projects, common models, FBX, shader test for dense. Skeleton mesh build nanite. Nanite, no. Cover scene, yes. Okay, I don't care. Same material. Paste. Okay, good. And now let's use this. So let's use this dense model. And here also. Better. More vertices to work with. That's good. Unfortunately, as you can see, the normal is not updated, which is a shame, to be honest. We may need a light source. Whatever. You can see that. Okay. We got this. Now, as you can see, this displacement is equal on the entire surface, right? So, fortunately, we can add our magnetic origin. This origin will be some number. Location is like this. So let's use the same for starter. 3,450, 3,000, 0. And let's calculate the distance to this origin. So distance this origin has to be component size, okay. Distance in 3D. Excluding material offsets. Material offsets meaning world position offset. That's important because otherwise this will feedback itself. So excluding material offsets. We select that here. Now let's visualize the distance. Let's remap that. Remap value range. Starting from 0 to magnetic radius. Remaps to 0 to 1. And let's put it into base color just for preview. Okay, it's white. Ah, the distance has to be reversed from magnetic radius to 0. Magnetic radius will be half a meter for now. Okay. We can do a trick already. We can, instead of doing 0, do it to smooth gradient. But I will show it in a moment. Ah, sorry, I have to remap the distance. Yeah. Like this. Now let's move that origin 100 1 meter up or 2 meter up. Yeah. So as you can see, there is some point, a magnetic origin, inward space, and when I move this point, it basically draws a sphere, a spherical mask. So a spherical mask is in its essence, it's a distance between a point and the world position of a pixel. Okay? So a spherical mask, just a point in world space and the world position. You calculate the distance and you remap it. For example, from 50 centimeters to 0, you remap it from 0 to 1 to have a graphical, gradient. 0 to 1 is the most, let's say, useful range. You need to saturate the result because this goddamn function doesn't do it by itself. Okay. Apply. It's good. Oh, Legumi reminds me that I was hating on that scalar multiplication in Houdini a couple of years ago when he was teaching me Houdini, for which I'm absolutely thankful to this date. And for his patience, which is a rare thing for Legomit. Okay, look, we have a distance. Now this can be a mask for our ferrofluid displacement. So let's multiply this displacement strength by this, and only then multiply the normal by the displacement strength affected by the mask. So look, this displacement strength noise, this thing is a radial mask from a point and yeah, just calculate the final world position offset. Take a look. So we got our ferrofluid. We move the origin and it moves. Maybe not that visible. Wait a second. Where's that point now? Oh yeah. Here it is. You know, this blackness may be visually good, but yeah, better. Look, the point. We move that point a little. And the mask moves. So if we have some point to which this magnetic fluid will, let's say, magnetize itself, gravitate towards or whatever it's called, then you will see that happening. So now we need that to animate itself. So there's noise. We can move the noise, but you will see it's a movement and it has to go rather up and down, up and down. So ideally we would have a 4D noise, but we don't. So what we can do? We can do a noise from 0 to 1. Probably. And we can add time. We can add time because this noise was from -1 to 1, right? So if we do a sine, it will be also from -1 to 1. So a sine. And here, time multiplied by animation speed. Animation speed could be 1. Let's see what happens. I don't know what will happen. Okay, cool. It moves. So sine, you know, the time grows. The time is growing, but the sine makes it wave. Szymon Steczek, subscribe. Welcome. I hope you're having a good time here. I don't know if you are on Discord, but if not, then please join. Invitation. Where is it? Server settings. Invites. Copy. Copy this. I can't copy. Adel, can you? Because I'm in a streamer mode. Nagomi says he's very patient while teaching. That's true. That's true. Oh, thank you, Nagomi, for the link to Discord. Okay, so take a look. Moves. Now the thing that doesn't update is the normal. As you can see, it's a weird normal. So it's not good. It's not good, and it gives us problem visually. The normal doesn't change, so Unreal doesn't know quite what to do about it. I wonder why it looks that bad, but still. Oh, what can I do about it? There should be some way to get normal out of this. Is it there? Height. Normal from height map. Height map, but height map is a texture. Ah, yeah. I would have to calculate the same for slightly shifted points and get a normal out of that. Normal, but there's nothing more. Nothing. Normal. Dynamic normal, flatten normal. Normal from function. Okay. Function 1, function 2, function 3. Oh boy. I guess yes. I'll just do a test. I will clean it up later, but just as a test. I'll copy that 3 times. I'm sorry. Put it to this function sheet. Okay. Height map UV offset. But how do you know? Normal map intensity, I don't know. And this thing should take a normal tangent space normal. I think no, or maybe yes, maybe yes. Coordinates. Why does it care about coordinates? Aha. Function UV2. Okay, so this will be weird. This goes to this, I guess. But it's UV. It's useless. Oh boy. UV is useless. Nah, it won't work. Calculating normals for where position offset is not a trivial task, says Adder. Not a trivial, but we can do it. So I need to calculate the same thing, but wait, it's 3D, so it's not that easy. I need a world position that's slightly moved in some direction. But in which direction? In the direction of the screen. Oh god. You need gradient, exactly. Exactly. So how to do what? Word to screen UV transform. Sounds good. What's camera vector with WPO options? Offsets. Eh. Can I calculate gradient on that noise? Legomir, I can, but I need to move 1 pixel in the screen space, but then project it towards space again. I think. Something like that. Okay. Wait a second. Let's do this. Let's do a very small number in x. Let's say minus 0, 0, 1. Let's do a small number in y. And just 0. Transform position from view space to word space. So this would be basically the middle point, the point very slightly to the left and very slightly to the top. From this, I will have a triangle, okay? And as Legomir says, the gradient, I will check the value of the noise here, the value here, and I will know that, for example, if this noise is higher here and lower here, then the gradient goes like this. The same with y. If in this place we have this displacement, right? And in this place we have that displacement, I will know that between this and this pixel, the value is growing. So out of this, I can get a normal because it's a triangle, right? So I know the normal of the triangle. That's theory. Let's see. That's exactly what this function, normal from function, does. It takes 3 places and calculates the gradient between them. Let's see. Legomir says that recalculating on vertex would be easy. Yes, but I don't know the neighbors. Vertex shaders don't know about neighbors. Only geometry shaders did, but they were removed in the latest Unreal. They were used for tessellation. I mean, maybe not removed, but not accessible. So yeah. Okay, transforming view space to absolute world space will give me these 3 points in world space. Now, out of this, I can calculate, I can add this offset to world position excluding shader offsets, okay? So this would be the same world position, but slightly shifted in screen space. So this will be a little tiny offsets in screen space. Okay. I'm adding 0. Fantastic. Perfect. This goes here, this goes here. So I have 3 times sampled the height. And I can calculate the gradients between them. So first, the difference, subtract from the new point. Actually, why did negative? From the new point, I subtract this, and here, from the new point, I subtract the original one. I have a gradient. I can append that gradient. I mean, to make it a vector too. Let's see. Huh, beautiful. Because displacement distance is here already. Why not do it here? Do it there. Not needed. Thank you. Also not needed. Bye. Okay. I know I could do a material function. I will if it proves to work. Okay, apply. I will break it. No. Okay. So that's the difference in screen space. Doesn't tell us much yet. Subtract. Okay, so I got the difference. It's fine. It's fine, right? Or isn't? I could actually do it differently. I could do height to normal kernel size, meaning, you know, the size of this testing triangle. I can multiply vector by scalar. Multiply 1, just like this, by that. And this kernel size should be very, very small. 0, 0, 0, 1. Save. Okay, I'm not yet sure what does it give us. Let's just see. So start previewing node. Okay, this is word position. And this will be word position with that offset. So let's increase the offset. Yeah, you can see it moving, right? 5 centimeters, 10 centimeters, 20, 25, and so on. So our offset should be very, very small. And add it. Okay. Very small. Let's try this difference thing. 0. Wait. This is weird because the difference should be 0, should be nothing with such a small kernel. Huh. That's weird. You got position, time, everything's the same. Really, the difference should be nothing. So why is it different? This should basically amount to 0. If we just added 0, nothing should change. 1. Should be like that, just black. Because these positions So 1 multiplied, 0 in view space to absolute, to absolute word space. That's incorrect, I think. It shouldn't be added. Sorry. Should be something different. I have a word position. So let's say, here's my camera, right? Here's the camera. I need to have the camera point, blue. I need to have a point slightly to the right of the camera and very slightly to the top of the camera. So here, such points, that's what I need. So I transform position. So I need, wait a second. There's absolute word position, sure. I need a point slightly higher in camera space than this. So what do I actually need? Good point. I probably need a difference. Yeah, I know what I need. I need a difference of this from camera. Camera position word space. Subtract. Difference from camera. That's what I need. And only this I add later. Let's try. So yeah, the difference. Start previewing. Now I will make it a little bigger. Yeah, take a look. It's a goddamn normal. So that's what I needed. I needed a difference. I needed this, not its word space position. That's not what I needed. I needed these tiny arrows. So that's why I subtracted the camera position from this positions of offsets. Okay, in camera space, not screen space, in camera space. And look at this. Out of a grayscale height, we are getting normal, kinda. I can increase or decrease the size of the kernel, let's say 0.01. More noisy, 0.1, 1, 10. 10 is too big. 5, 4, 3. 1 is okayish, maybe half, maybe 1. And now I need also normal strength. So out of this. However, it gives us some normal. I don't know if what space. Screen space? Maybe? In some weird space. What to do about that? Because it's normal in camera space. Or no? It is. So I need to transform that. Probably. I need to probably derive Z also. Derive normal Z. And now I need to transform that from view space or from camera space to word space to tangent space. Probably. I don't know. Maybe not. Maybe? I don't know. Is it correct? And let's move it to normal and let's see. Abdel says it's from 0 to 1. I'm not so sure. By the way, let's make it weaker. normal strength. Okay, there is something, but it's definitely wrong. Maybe it was word space. No, no, it's camera space. Okay, from camera space to word space normal, and let's disable in the material settings. That was about using tangent space normal off. Let's see now. No, tangent was okay. But it's still wrong. Wait a second. Because it looks like this. It's in the wrong direction. Y is definitely in the wrong direction. So Y should go -1. Nothing changed? What? 0? Well, -1? Nothing changes. Why? That's weird. That is weird. Subtract. Wait a second. If I don't figure this out, we'll just skip that because let's not waste time. But still, it's weird. That's 0. Okay, I don't know. I know what we should do. It will work on flat surface. And I need to add existing normals. That's a good point. However, no, because normal is in tangent space, so I don't need to. But if it was in word space, I need. Okay, so let's disable tangent. Let's just get pixel normal, no, vertex normal word space. And let's add, actually, as you said, let's add this. Let's normalize. Because this normal is not in Word. Let's try now. Huh. Wait, if I just do this, will it work? Okay, let's disable this word position offset for now, not to distract us. Yeah, okay. The vertex normal works. And now adding this thing. But this thing, it should look different. It should look just different. And it's blue. What the hell? It's blue. So if the normal was actually why? It's so hard. Adding normal strength is 0. What? Thank you. Okay. Okay, normal strength is 0, but why there's no green or something? Because it's in one space. Okay, so now it's pointing up and pointing left, which makes sense, I guess. Let's try. So normal strength 0. This is weird. Because there's this blue thing. Look. That is adding. some weird stuff from camera space. So zero in the normal zero in camera space is not what we think it is. View space. How to actually get? Ah, because there's derived normal z. We don't need that, I think. Comparison errors. Why? Because we have no z. Oh god. But how to derive a proper normal z when there's nothing? We don't need z. Vector 2 plus vector 3. Okay, Adel, I know, but what to do about that? Because I have a vertex normal. It's like that. Okay. And I need to add, let's say, an offset to this. So this was quite okay-ish, this thing. I need to transform it from whatever space it is in to the word space. Aha. Transform it. But is it correct now? Can transform. Aha, no z. Z in view space would be 0. Normalize that. Then transform. Okay. It's of course too strong. So I need to multiply it by normal strength, which is just cut out, whatever. Normal strength. So no, that's, as Adel mentioned, it's a hard thing to get a normal for word position offset. Okay, normal strength is 0. Cool, works. So this was just the order of operations. So we got that kind of normal derived from, 3 pixels in a very, very similar spot. So again, this. Okay. What I did is I get my camera position in the middle of the screen and I get a pixel slightly to the right, a pixel slightly to the top, and I calculate the difference between the middle of the camera and this. So based on that, I know, for example, that here the green sampled black, yellow sampled white. So the value was decreasing, okay? It's going down. Now red sampled white, this sampled white, the value is slightly brighter or even the same. Based on this, I get a gradient. And if I have a gradient, I have a normal of 2 axes. So yeah, this worked. And I'll take a look. I'm just appending 0. I have a normal in the view space out of these 3 points, just by subtracting x out of x from x, y from y. The distance of this tiny, difference is here, height to normal kernel size. So wait a second. Classical thing I need to tell you, for those of you who don't know. I got patreon.com/techardade. Okay, and if you take this higher membership, then you also get project files with this. So in these project files, you can easily see how this was done. It's not that complicated, to be honest. So I recommend that, and I also will give a replay of this stream quite soon. I think within a few days. Here you have it. Perfect. So now we have a normal. Now we have a normal. Always normalize after such weird operations like adding normals. because normal have to always have a length of 1. Normalize basically ensures that. So now we can get back to our world position offset. Displacement distance, maybe weaker, maybe 5 centimeters. Save. And yes, it moves and it calculates normal for itself. Now the normal strength also has to be affected by this radial mask. So we need to multiply on which level? On that level as well. So lerp between this new normal and the standard normal, using that mask as the alpha. And normalize that. And now it should only apply on the top. Woke as fuck, ask on chat if I don't write shaders with code. So in Unreal, to write shaders in code, I only can do this custom node. And here, you put your code here. So like, let's say normal x or float free normal x equals ddx, and my, for example, height 1, height 2, and as you can see, it's clunky, not readable, so you have to do this in external software like VS Code and paste. And yeah, it's good, I think, for tiny expressions, but not for a big shader. However, I know that you can write your own USF files, but it's slightly more complicated. So at work, I've often written shader code, and I think I got pretty good at this, and optimization and so on, code clarity. But in Unreal, just out of how easy it is, I prefer nodes. Not how easy nodes are, but how complicated it is to write code. In Unity, I will definitely write code. Especially the shader code is not that hard. It's really simple. So yeah, Ferrofluid is moving within the radial mask. And for those of you who joined later, a radial mask is a very simple thing. You just have an origin in world space, a vector, and you measure distance to it, and you remap it from 0 to some radius to 0 to 1, and saturate, so clamping it, and that's your radial mask. Okay, so this thing is calculate normal out of height functions. Okay. Code Tech Ninja says that nodes are easier for beginners to learn. Okay. I think at dev that this normal matches this world position offset, kinda. Now the problem is there's some weird shading issue, and I don't know what is it related to, but it looks like it's related to some lumen things. Let me try movable for sure. But lumen, where is it? It should be in this, in post process, lumen. Yeah, reflections, screen space. What? Where is it? And global illumination, none. Huh, still bad. I don't know what that is, but if you see that, if they go below a little, the normal is okay. Normal is correct. What happens is it cuts through something. Distance field, maybe? Oh, maybe distance field occlusion. Maybe distance field occlusion. Can I disable it? DFAO. How can I disable ambient occlusion? Distance field ambient occlusion? I probably have to go to skylight and disable that. Oops, nothing. Huh, still bad. I don't know, it clips through something. Or maybe it's distance field shadows. Directional light. Distance field shadows are off. I don't know. I just have no idea. R distance field AO 0. Nope, it wasn't that, but thank you for the command. Scalability medium. High, epic. I don't know what that is. This is something. But what? Anyway. Ferrofluid kinda works. So now what we need to do is to make it controlled from gameplay. And this will be the last thing for today. Looks like normals are inverted, says Piatnashkin. But are they? Let's try the different strength. This is strength 0. Oh no, look, just moving the worst position offset does this. I don't know what it is really. No idea. What if I place it on the floor? This material. Yeah. Where is my ferrofluid vector? Ah, it doesn't have vertices. We can't check that way. What the hell? No idea. So, wait again. Model. Stop previewing. Yeah, exactly. On the floor with 4 triangles. 2 triangles. How can I check this, Piatnashkin? That these normals are wrong? Because I think it's not normals. Look. I disabled normal strength. And the problem is there. The worst position offset gives the problem. If I disable that, okay, disable that, bring back the normals, they are okay. They are okay. So that's unfortunately something else. But I don't know what. Woke as fuck says that they are using Unity at university, but afraid a bit that they should learn Unreal because money is with big studios and those studios use Unreal. Honestly, if you care about money, more money is to be made in the mobile, and mobile is Unity based most often because of the compatibility with a very wide range of devices and because of how easily you can scale performance of Unity. Adel asks if I can stop moving noise. I can do the speed 0. Okay, now. And what now? Yeah, and you can see Adel here that there's already a problem. Supak says they are seeing many Unity hard position. Exactly, it's very popular. So don't worry. It more relies on the fact if you want virtual production, super realistic, then go into Unreal. Or let's say this mid-core games for, you know, gamers, where you have realistic monsters and science fiction and yeah, this kind of stuff. But for casual mobile games, Unity is the way to go. And there's more offers of Unity. Next, maybe less prestigious sometimes, but more in terms of the breadth of the market, I think, right now. But Unreal is getting more and more popular, just in the different places. Okay. Add that, but this is not about normal. Normal doesn't matter. Look. If I disable normal, I still have this problem for word position offset. It's when it's clipping with something. Some distance field or some other shit, I don't know. We'll figure it out someday. As you can see, normal matches this word position offset, so I don't know what's that. I just have no idea. Okay, let's bring back the animation speed. Yeah, Ferrofluid, moving. Now, last thing. This point is static. We have to set it here. So let's make it dynamic. Take a look. Magnetic origin. We go to my favorite. Custom primitive data. Enable. Save. It will disappear. Sure. Compiling. Okay, disappeared. Now, let's make a blueprint out of this. So, we need a blueprint. BP. Type actor. BP Ferrofluid. We put this little guy inside here. Transform 0, 0, 0. It's okay. The material will be that material. Ferrofluid. Oh, come on. Okay. We have it. Now, let's add a variable of type magnetic origin. The name doesn't matter. Type vector. Instance editable. And now if you click instance editable, this icon, you got show 3D widget. And take a look. Show 3D widget. Save. And there, if I place that blueprint, this should have a scale of 1. If I place that blueprint, I get a point here called magnetic origin as the variable. And now I can select this point and move it. Move it because this is a vector variable that has show 3D widget enabled here. So I can edit the value of the vector in words space. Oh, actually in local space. And now I will just send it event graph. So every frame, every tick, I will get this mesh. Let's rename it. So step mesh. I will set vector custom primitive data vector free data index 0. The value will be magnetic origin in word space. So magnetic origin get word transform. No, sorry. Get transform. Transform of self, basically. Oh god. Get actor transform. I'm sorry. Or actually no. Let's get actor transform. Get actor transform. Zakiko, thanks for following. And sorry if I mispronounce your name. Tell me how to pronounce it properly. Get actor transform. Yeah, this. If I have my own actor transform, woke as fuck. Also thanks for following. Transform location. And look, actor transform transforms this local point to word space. That's what it means to transform a location through an actor transform. Because if I hover, it says get the actor to word transform. So I send this to material through custom primitive data. And again, in the material, I ticked in the parameter use custom primitive data, the same index, so 0 here, 0 here. And that's it. That's it. I shouldn't do it on event tick. I should pack it into a function and call it update magnetic origin or update material. And I also do it not on event tick, just once on begin play. And I do it also in construction script. And that's it. Look, I move the magnetic origin, disappears, appears, disappears, and so on. That's how it works. I just move this little tiny point, beautifully updates itself. Okay, how do you like it? Nice? So today we realized a lot because we did metal and ferrofluid. And the next will be the ethereal blue glow and aurora borealis. And yeah, send more ideas if you have for the next one. Take a look. That's the first one. And that's the last one. So again, patreon.com. I will do a replay of this. Put a replay there in probably less than a week. And together with this will be the project files. So all the textures and materials we created today. But Nashkin says that the glowing thing is Niagara domain. This thing. Maybe, but we can play with some 3D noises, maybe. Volumetric material. Kotek Ninja says thanks for the stream. Thanks for being here. Thank you all for participation and for cheering me up and for helping along the way. So yeah, we got this. And yeah, see you on the next one. Cheers.